All right. Let's start first with what makes a function a function. You remember, listen, remember when we did the mapping diagram, right? And let's say I had a 2 and it was mapped to a 3 and a 4. Okay? Was that a function?
No.
Why? Because I can only have my x can only be mapped to one y function. Okay? I can't have an x value that is mapped to 2 different y functions. That's what makes a function a function. Okay? A linear function, what's the root word of linear? Line. Okay? So it's a function that makes a line. So a linear function has to apply to 2 principles. It has to be a function, first of all, and then it has to be a line. And we'll talk more about that in a second. All right? So, is this graph a function right here?
Yes.
Okay? How do I know?
Because it's a line.
Okay.
Or also it's hitting like all like, I don't know.
It's
hitting all like,
with no overlap.
yeah.
Yeah. So basically it passes that vertical line test, right? When I take this vertical line right here, it's only going to hit that function at one place. Okay? And of course, yes, we can see that it's a line. Is that a linear function? Is it a function? First of all, let's talk about that. Is this a function? When I take this vertical line right here, and I take it across the function itself, is there any place along this function where it touches that graph at more than one place?
1, 0.
No. There's no place it touches the function at more than one place. Okay? So we know that it's a function. Okay? Is it linear? No, because this is not a line. Okay? So this is a function, but it's not a linear function. Is this a linear function? If I take this vertical line, at any place along this function, does it hit the graph at more than one place? Yeah, right there. Think about that for a second. Okay? If I take this vertical line and I put it over a vertical line, it hits it at every place. Okay? So this is not a function. Okay? Because it violates that vertical line test, which says that you cannot have a vertical line that touches that graph at more than one place, and we can see here that touches it at all of them. You with me, Gainer? Okay. All right. Now, is this a function?
No.
Okay, good. Not a function, because if I take that vertical line, it touches the graph at 2 places. Okay? So therefore it's not a function, including on a line. All right. Now, you're going to be given a table of values, or you're going to create a table of values. Okay? So I'm going to give you a set of ordered pairs, basically. You're going to fill out the table, put all your x values here, all of your y values here, and then you're going to tell me whether or not this is a linear function or not. Now listen to me. Everybody pay attention. Okay? The reason why I've done this is because you can see that here I have the same set of differences on my y and the same set of differences on my x. So if it's the same set of differences all the way, each way, then this is a linear function. Okay? Now, if it's a linear function, that line has a slope. Okay? And we're going to talk more about slope, but the slope is the change in whatever the y values are over the change in whatever the x values are. What's the change in the y values for this table? -3. And the change of my x values is what? So the slope of this line is -3. Okay? Is this a linear function? No, it's not. Why?
It goes from 6 to 3 to 2.
I don't have the same set of differences. Okay? So if I don't have the same set of differences, this is not a linear function. All right, so you're going to take this table of values, or this set of ordered pairs, fill out a table of values, and then you're going to tell me if it's linear or not. And if it's linear, tell me what the slope is. All right, so we've filled out our table of values. Okay? What am I doing each time to the x values? I'm adding 4. What am I doing each time to the y values? I'm adding 3. So I'm doing this the same time, I'm adding 3 every single time. There's no change in that. So therefore, I know that it's a linear function. So therefore, it has a slope. And I'm going to look for the change in y values over the change in x values. The change in y values being what? 3. The change in x values being what? That's my slope. All right, let's do this one more time. All right, what are we doing each time to the x values? Adding 2. Here we subtract 12. Here we subtract 4. Here we add 4. Here we add 12. Clearly not the same. So therefore, this is not linear. Okay? All right. I'm going to skip through that. Listen to me. We've already talked about slope-intercept form a little bit. Y equals mx plus b. Okay? We're going to talk about standard form. Okay? Standard form kind of looks like this. Some number a times x plus some number b times y equals c. An example of this would be 2x plus 3y equals 4.
I don't know if you noticed, but he was blind. That was a lot of confused. I don't know why, but I was
Okay. Thank you.
good job.
I have a spot on Sesame Street apparently. Okay.
I can see.
All right, now, if I'm looking at an equation, you have to be able to tell whether or not it's linear or not. Let's just look at an example here real quickly between these two real quickly. Y equals mx plus b. That would be something like y equals 3x plus 4. Okay, now, if I'm looking at an equation, it is not linear if the exponent for the x value, or any variable, is greater than 1. Okay, you have to know these rules. Right, Jason? That clock ain't going to move any faster by staring at it. Okay?
Write them down.
Exponent for x cannot be greater than 1. Now, number 2, no variable in the denominator. Number 3, I cannot multiply my variables together. And those are going to be the ones that we're going to work with in this class. I know, I am so bad with this tablet. It is awful. I wish I could use my... All right, so in this case right here, 3x squared plus 2 is not linear because the x has a value, or the exponent for the x is bigger than 1. I cannot have a variable in the denominator, so I can't say y equals 2 over x plus 3. Okay, that's not linear because the x is in the denominator. And the last one, I can't have xy equals 3 or something like that. Okay, we can't multiply the variables together. All right, so this is kind of the rules. all right? And I've put this on your homework so that you can remind yourself about them, all right? Now, is this a linear function? We're not going to graph it.
Yeah.
I want you to write this in standard form. This is a linear function. It doesn't violate any of the rules. So I want you to write this in standard form. We need to move the x and the y over to the same side. So I'm going to move this 2y over here. And so I have x minus 2y equals 4. So when I ask you, what is the value of a? What's the number in front of x? 1. What's the value of b?
2.
Negative 2.
Negative, sorry.
And c would be what? 4. Is this a linear function? No. Is this a linear function? Yes.
Yes.
Okay, it doesn't violate. I don't have any exponents that are larger than 1. I haven't multiplied any of my variables together. None of them are in the denominator. Put this in standard form and state to me what your A, B, and C is. Form, we're going to subtract the 5x to both sides. Now again, the number in front of the x and the x come first. So negative 5x plus y equals negative 9. So in this case, my A is negative 5, my B is positive 1, and my C is negative 9. Okay? All right, so on a side note, is that linear?
No.
Do I have an exponent that is greater than 1? Do I have two variables multiplied together? Do I have a variable in the denominator? And that's linear. Okay? So this is a linear function. Now we want to write this in standard form. Well, understand, I don't have a y here, right? So let's go ahead and say it's x plus 0y equals 2. Okay? That's standard form for this equation right here, where my a is 1, my b is 0, and my c is 2. Okay? All right. We're going to skip that for now. All right.